Alright, this is section 5.6, I believe. Let me see real quick. It's 5.6, and we're talking about the fundamental theorem of algebra. Uh, Basically, if you read all this, I vaguely understand what all that means. But here's the rundown. Here's the layman's version. Whatever the degree is, that's how many solutions. So if your degree is 4, you're going to have 4 solutions. Remember, the degree is the highest exponent. Is if your highest exponent is a 3, you have 3 solutions. Alright? It is straight up that simple. So, for number 1, we're going to have the degree is 3, so therefore there are 3 solutions. For number 2, the degree is 5, therefore there will be 5 solutions. Now, they may not be real, they may not be rational, you may get some square roots in there, you may get some imaginary numbers, things along those lines, but still, there are 5 solutions. Okay? So we're going to burn through those, see how we do, and go from there. So, number 1. They give us x cubed plus 7x plus 16 plus 12. We already talked about this. The number, the highest exponent is 3, therefore the degree is 3. And we're going to go ahead to get, since this is not easily factorable, like I can't do difference of squares on those to get the same thing. It just doesn't work very well. So we're going to put this in our calculator, see if we can find a reasonable solution. Give me just a second. And there you go. Now, it may not be readily easily be able to see on your calculator the way this works, but there's a double root right there, and it looks like it goes through -3. So it looks like we have 2 -2's and 1 -3. And on your calculator on normal zoom, it looks like it comes up, flattens out, and goes back up. You really can't see it, but if you zoom in, you start to see the shape a little bit better. So don't forget, sometimes you just need to zoom in. So here's what we're going to do. We are going to do, what's it called? Synthetic division. So I'll start with the -2. -2, that's, we got 1, 7, 16, and 12. So remember, drop it down, multiply, add, multiply, add. So 1, what's it, -2, that's -2. That makes it a 5, -10, +6, -12, and 0. Good. We have a remainder of 0, so that means -2 really is a solution. Now, one thing we can do, we don't necessarily have to rewrite this as a factor, like x squared. We don't necessarily have to go x squared plus 5x plus 6 and factor this down to x plus 2 and x plus 3. Which would give us our other two, -2 and -3. Now, while I think that's quicker, another way of doing this is, since we already know, we're pretty sure that there's another one at -2. Let's just do it again. Drop down the 1. 1 times -2 is -2. 5 minus 2 is 3. 3 times -2 is -6. That's 0. Good. We have another remainder of 0. So this one is x plus 3. And when we set that equal to 0, we get x equals -3. So it's just a negative. So when we're all said and done, either way, we get x equals -3 and 2 -2's. It was just 2 different ways of doing the same thing. This one we did synthetic division once until we got to a binomial. And this one. This way I saw that. The other way I saw that and said, oh, I could factor that real quick, and got the same 2 answers. So it's just 2 ways of doing the same thing. Alright? Let's do numbers 2 real quick. I'm going to pause, put this in my calculator real fast. I'll be right back. Alright, we get something that looks kind of like this. It looks like I have a double root at -1 and a single root at +2. And the fun part about this is they need 5 roots altogether. So we only found 3 just by graphing it. So we need to whittle this down to find the other 2, and it's very likely they're imaginary or rational, or just straight up don't fall on the graph anywhere that we can find. So here's where we go. Start off with, pick one. I'll do the -1 first. I like multiplying by -1. So My coefficients are 1, 0 for the negative 4. Don't forget, if there's no x to the fourth, you got to put a 0 there. Negative 2, negative 12, and negative 8. Lots of negatives on this one. So remember, drop down, add, drop down, add, drop down, add, multiply, add, multiply, add. So 1, that's negative 1, that's positive 1, that's 0, 0. Negative 2, that's positive 2. Negative 10. Okay, I think I did something wrong here. Negative 1 times negative 1 is negative 1. 0 minus 1 is negative 1. Times negative 1 is positive. Oh, that's what I did. Let's start erasing. Erase, 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 erase. 1 plus 1 is not 0. 1 plus 1 is 2. 2 times negative 1 is negative 2. Negative 2, that's negative 4. Positive 4, that makes it a negative 8. Times negative 1 is a positive 8, and 0. Yay! So that one is actually a root. And we thought negative 1 was a double root. So we're going to try it again. So that's, again, got a remainder of 0. So we know this is one of our solutions. So remember, drop down, add, drop down, add. So 1 times negative 1 is negative 1. That's negative 2. Negative 2 times negative 1 is positive 2. That's 4. That makes it a negative 4. Negative 8. Negative 8 times negative 1 is positive 8. And then we get a 0. And then we got this guy right here, this guy right here. Negative 1. Sweet. And actually, just from looking at this, I can tell you I could use a difference of squares. Or we can go ahead and try the 2. Why not? Let's keep on going. Let's do the 2. 1 times 2 is 2. That's 0. 0 times 2 is 0. That's 4. 4 times 2 is 8. That's 0. Yay, we got another 0 over here. So we know 2 is a root. Alright. Last but not least, we have this guy right here. So this is x to the 0, this is x to the 1, x to the 2. You don't have to write that, but you do need to realize it's there. So I've got the last one. Got an x squared, I got nothing there, and I got a plus 4. Now this is not a difference of squares because of that guy right there. If it was negative, we could do it. So what we're going to do, we're going to set it equal to 0. Where's my pen? There it is. Set it equal to 0, and we're going to solve. So subtract the 4 over, x squared equals negative 4. And then square root both sides. Remember, when we square root a square, we get two answers. We get a positive and a negative. And then we do the square root of 4 is 2. But the square root of negative is imaginary. So this has two imaginary roots. So last but not least, here we go. So for this one, we got x equals negative 1, another negative 1, a 2, and a plus or minus 2i, which that's a positive 2i and a negative 2i. So this is your final answer. You could not have gotten that from a graph. Alright. Alright, this is number 3. I went ahead and graphed it real fast. But the number of solutions, remember, the number of solutions is the same as the degree of the polynomial. So, highest exponent is 5, therefore the number of solutions is 5. And if you look over here, we really only see 3 plausibles. There's 2 1s and 1 negative 1. And again, we don't know that for sure, we just know it looks like that. So we do have to prove it one way or another. So we're going to factor those out, and we're going to go from there. So let's start with the negative 1. Why not? So we got a negative 1, a 1, negative 3, 5, negative 1, negative 6, and a 4. And let's do synthetic division. Let's kick this pig. So drop down, multiply, add, multiply, add. So 1 times negative 1 is negative 1. Negative 4 times negative 1 is 4. That makes 9. That's negative 9. Negative 10. That's 10. 4. Negative 4. 0. And if you don't believe me, pause. Watch that again. So we do know that negative 1 really is a solution because of the 0. We have the point. Just remember, whenever we try to divide one of these by synthetic division, this is your x value, and that's your y value. So we know this has the point negative 1, 0. So negative 1 is an x-intercept. Alright, let's try the next one. Let's do it again. this time. We did the negative 1, so let's do a positive 1. 1 times 1 is 1, so that's negative 3 times 1 is negative 3. That's 6 times 1 is 6. That's negative 4 times 1 is negative 4. That's a 0. Yay! We got another 0. So we got negative 1, we got positive 1, and then, pardon me, I'm just looking at this again, and that does not factor by grouping very easily either, because I can't pull something out of this side over here that would make it equal to this left side. So we're just going to do it one more time. Let's do another 1. So 1. 1 times 1 is 1. That's negative 2. Negative 2. That's positive 4. 4. 0. Good. Got another 0. So we have confirmed that we have a double root at 1 and a single root at negative 1. And we are left with a polynomial, x squared minus 2x plus 4. And you could try this all day long. This one is actually not factorable. There's nothing I can multiply that adds up to 4, that multiplies to 4 but adds up to negative 2. So we are going to have to use, remember, negative b plus or minus the square root of b squared minus 4ac all over 2a. Yay, the quadratic formula. So here we go. Negative b is a positive 2 in this case, plus or minus the square root of b squared. Negative 2 squared is 4, minus 4 times a, which is 1, times c, which is 4, all over 2 times a. 2 times 1 is still 2. So here we go. That's 4 minus 16. That's negative 12. So that's 2 plus or minus the square root of negative 12 over 2, which I'm going to go over here and just reduce the square root of negative 12 real quick. Negative 12 is what? 4 times 3. That's negative 4 times 3, which makes that a 2i on the square root of 3. So that's 2 plus or minus, actually let me zoom in so I can write this a little cleaner. 2 plus or minus 2i on the square root of 3 divided by 2. Which, yay, all of these can cancel each other out, which leaves us with 1 plus or minus I on the square root of 3. So we have our 5 roots. We have a negative 1, we have a 1, we have another 1, and then we have 1 plus or minus I on the square root of 3. Those are our solutions. And we got one more. Alright, this last one. Number of solutions. Highest exponent is 4, therefore the degree is 4. And so therefore the number of solutions is 4. And to get kind of a starting point, we're going to graph it and see if there's anything reasonable. Alright, so if I look on that graph, this is kind of what you end up seeing. I really have no idea if, I'm pretty sure that it connects under here and goes off in that direction, simply because my leading coefficient is a positive number, but I really can't tell it too well from the graph. All I really can tell is the fact that I'm pretty sure it crosses at negative 2 and positive 3. So I'm going to start by trying to prove that that is actually the case. So start with negative 2. And then we've got the coefficients 4, negative 3, 6, 2, and negative 60. So let's do the business. 4 times negative 2 is negative 8. 9, 10, 11. That's negative 11. Times negative 2 is positive 22. Plus 6 is 28. Times negative 2, that's 2 times negative 2 is 28 times negative 2 is 56. Did I write this down right? Alright, so Mr. Hunter just realized that he's a moron again. The leading coefficient is not 4. The leading coefficient is 1. That will change everything. So it's 1. The degree is 4. So 1, negative 3, 6, 2, negative 60. And that's going to make a big difference. So that's 1 times negative 2 is negative 3. That's negative 5 times negative 2 is 10. So that's 16 times negative 2 is negative 28. No, that's negative 32. Negative 32 minus 2 is negative 30. Times negative 2 is positive 60, which those add up to 0. Okay, that works much better. helps when you write down the right number. So we just proved that negative 2 is an actual factor. So let's try the 3. Drop down the 1. 1 times 3 is 3. Minus 5 is 2. 2 times 3 is 6. 6 plus 16 is 22. Did I write it down wrong again? 2 times 3 is not 3. 2 times 3 is 6. Mr. Hunter's going way too fast. 1 times 3 is 3. No, that's right. 3 minus 5 is negative 2. Negative 2 times 3 is negative 6. That goes down to 10. 10 times 3 is 30. That's a 0. There we go. So we've just proven, because the roots are 0, the remainder is 0, those are both actual factors. So now we're left with x squared minus 2x plus 10, which, yeah, nothing multiplies to 10 but adds up to negative 2. So we're going to have to use our quadratic formula. So let's go over here and do it real quick. Remember, that's negative b plus or minus the square root of b squared minus 4ac all over 2a. So here we go. Negative b, so negative 2 is a positive 2, plus or minus the square root of negative 2 squared is 4, minus 4 times a is 1, c is 10, all over 2 times 1, which is 2. So that's going to equal 2 plus or minus 4 minus 40 that's negative 38. So that's the square root of negative 38 divided by 2. So let's reduce that radical right quick. The square root of negative 38. That's not divisible by 16. It's not divisible by 9. It's not divisible by 4. That's interesting. Is that not divisible by any perfect square? Did I do that right? No, I did not. That's supposed to be a 36. Mr. Hunter's going way too fast. 2 plus or minus. Mr. Hunter also likes to speak of himself in the third person. He's a bit of a weirdo. Which negative 36, I know that factor. That reduces. Because there's a 9 and a 4 in there. So if I get... Well, negative 30, the square root of negative 36 is 6. So it's 2 plus or minus 6i divided by 2. Which, again, I can divide all those by 2, so that equals 1 plus or minus 3i. So there are your 4 roots. I got x equals negative 2, positive 3, and 1 plus or minus 3i. Sorry, imaginary numbers and radicals are not going away anytime soon. They are still very legitimate answers. There you go.